Good morning, everyone, and welcome to my first post of my YouTube channel for eddycurrent.com. My name is Ed Korkowski. I started eddycurrent.com, a resource for everything related to eddy current testing. I want to tell you a little bit about my career path and what got me here and what I do for an energy company with regards to eddy current testing. Right now it's a Sunday, and I'm working on my website, eddycurrent.com, which you can see behind me. And that's just a web page that has eddy current resources. Whether you are a company selling eddy current testing equipment, or whether you're a young person wanting to learn more about eddy current testing, maybe do some research where you want to go to school for eddy current testing, or if you're already in the field, you can go find out where to go get eddy current training. You can learn about how to get certified. There's all sorts of resources, tools, formulas, study guides, research options to research about eddy current, all those great things, right? But getting back to what I do, I work for a large energy company, and I'm a non-destructive testing expert, specifically in eddy current testing. Now, eddy current testing is a non-destructive test method that uses electromagnetic induction to inspect metal conductive objects. I specifically work with non-ferromagnetic tubing most of the time, but I went to school for non-destructive testing back in the late 80s, and I got a job working for a nuclear service company called Framatome, and it changed its name to Areva, and Babcock and Wilcox, and back to Framatome. Now I worked there for 15 years. Then I went to work for an energy company, and now the old company I used to work for comes to my energy company and does inspections for me. So the roles kind of got switched around a little bit, but I've been in the eddy current business the whole time. Now, specifically what I do is I inspect tubing using bobbin probes most of the time, and then we also use array probes and rotating probes. Well, what does that look like? Well, this is an older test instrument, but this instrument shows what eddy current data looks like. And these signals that you see on the screen are actually flaw signals that come from a calibration standard, which is what you're looking at here. And this calibration standard has a bunch of known flaws or defects, whatever you want to call them, ranging from flat bottom holes, maybe 20% deep, to a through wall hole. And then this white area towards the top has some tube support rings that actually have some mechanical wear fretted into the tubing. So we calibrate our test instrument to recognize what those signals look like. And then when you go inspect actual tubing, that's an actual probe that's kind of all spooled up right now. But that probe's 110 feet long, and it would get inserted into a tube by robot, and it would, once it inserts all the way through the tube, it gets retracted at about 40 to 100 inches a second, and you're recording the data on the pullback. Then we analyze the data, and then we can make recommendations to the site, which is me, as to what tubes are damaged, what tubes are okay, and what tubes need to be plugged, that's taking them out of service, or potentially repaired using things like sleeving, or maybe re-rolling the tube expansion joints, things like that. So that's basically what I did for my job, but you know, that's a big job when you work for an energy company. Because right now, the company I work for has 4 different nuclear sites, and each of those nuclear sites have a number of pressurized water reactor steam generators, nuclear steam generators. And each site has anywhere from 2 steam generators per unit up to 4 steam generators per unit. And those steam generators can have anywhere from 3,200 tubes for the ones that we have, all the way up to around 8,000 tubes each. Now, if you think about it, and those tubes are, I don't know, let's say they're 100 feet long, and you've got 8,000 of them. I mean, that could be hundreds of miles of tubing per unit, per inspection. And you have to inspect 100% of that tubing full length to make sure that you don't have any flaws that exceed, accepted criteria, right? And all these tests and inspections are very regulated. And, the Nuclear Regulatory Commission keeps an eye on all the power plants to make sure they're doing inspections at the right intervals and also to the right extent with the right scope, using the right probe technologies. And, the folks that evaluate or analyze this data have to be trained. So all that stuff is regulated and monitored. Now, there's only a number of people in the whole world that are qualified to analyze steam generator tube inspection data. And that number seems to be getting smaller over the past few years as the Eddy Current professionals have been retiring. So that creates sort of a problem, because you still have to inspect all the tubes from all the different power plants, but when you don't have the people to do it, you're in trouble. So what we've been doing over the past several years is using automated analysis to a larger extent. So basically what we do is we train computer systems to go through and analyze the mountainous volumes of data that we have. And, of course, the systems have to be trained correctly. And each automated system has to pass a site-specific performance demonstrations for every site that the system is deployed to. And it gets tested based on rigorous criteria to make sure that it finds all the flaws that it needs to. And what we use the automated systems for is to do a lot of the heavy lifting, which is to analyze the large volumes of data produced by the various probes, and then leave the more critical decision making up to the lead analysts that are in charge of the inspection results. Now, we use a lot of different types of qualified people in the Eddy Current inspections, and those are broken into levels called level 1, level 2, and level 3, generally. The level 1s, first of all, you're a trainee for a while, so you're helping out the level 1s, 2s, and 3s, mostly the level 1s and 2s. And then after you get a certain amount of hours of trainee time, you can take the test for level 1. Once you get your level 1 certification, you can set up the equipment, you can record data, but you can't interpret results. That's left up to the level 2s or level 3s. And for level 2s that evaluate data, they can look at lots of types of data, but they cannot evaluate nuclear steam generator tube data because you need specialized training for that. Once you get that specialized training, a lot of companies call that a level 2A data analyst. And you can also get an additional certification through EPRI, which is the Electrical Power Research Institute. And that is called the QDA, or Qualified Data Analysis Training. And that will give you a certification that you can be used to analyze nuclear steam generator data. And there's lots of that data out there worldwide. And now with the new push for nuclear, it's clean energy, produces a lot of power. A lot of these data centers need a lot of power. So they're actually bringing some nuclear plants back online. They're currently building nuclear sites all over the world. And there's probably going to be an expansion of new nuclear in the United States. So that's good if you want to get into the tube inspection business. So that in a nutshell is kind of my job. Now I oversee not only the steam generator inspections, but also all of the other non-steam generator heat exchangers, which can be up to 100, 150 heat exchangers per site. Now, usually the steam generators are all tubed with Inconel 690, which is non-ferrous. It's a type of steel with chromium, nickel in it, but it's very strong, and it can extend very high temperatures and pressures. That's why it's used. It's also expensive, right? But when you get into the less critical heat exchangers like feed water heaters, lube oil coolers, fan coolers, those are often tubed with other metals, non-Inconel. Some of the material types are copper, nickel, aluminum, brass, stainless steel, and they come in a wide variety of tube dimensions, as you can imagine, different lengths, different ODs and IDs, and different wall thicknesses. So you need a lot of training to be able to figure out how to configure your probes and equipment to analyze those different types of tubing and different tubing sizes. One question I often get asked is, well, how do you figure out what test frequencies to use? Funny you should ask. Years ago, I came across this tool called the Eddy Current slide rule. This was developed at Battelle Labs in 1968 by Russell Brown. And over the decades, people stopped using this less and less. And it's not because it's not a great tool. It's because, a lot of information gets lost over the years, right? And it seems like the younger generation likes black boxes and apps that sort of spit out the answer. But when you use the slide rule, you have to put a little time into figuring out how it works. But once you figure out how to perform the operations, you can easily use the slide rule to calculate test frequency, standard depths of penetration, that is how deep your eddy currents penetrate into the test material. You can calculate what your separation phase angles will be using different frequencies on different materials. It's basically a calculator tool that can be used for many different things. And although I've been in the business for almost 35 years, I continue to use the slide rule on an almost daily basis. So in my job, I used to, be a helper and set up equipment. Then I would record data. Then I would write reports. Then eventually I became a level 3, and the level 3 does a lot more administrative and technical work. So they develop procedures, they oversee the work that's performed by level 1s and level 2s. A lot of times level 3 is who will be overseeing an entire inspection, so making sure it's done right, that the right people are used, that the inspection results make sense, that the results get reported properly through the right channels. And since I'm an energy company employee, I have to make sure that all of my bosses and management are aware of what the inspection results are, because that can affect your refueling outage schedule. If there's a lot of repairs, that can cost a lot of money. So that, of course, concerns the management. And you need to get the plant back online so it can be producing electricity to sell to the customers. And so everybody's happy because their air conditioners are running and their lights are on, or if it's cold out, that it's nice and warm and toasty in the house. So when you work in the eddy current testing field and you work for an energy company, you are very much an integral part of keeping the power supplied to the grid to keep your customers happy and safe, because electricity is needed, as you know, for things like hospitals and public safety, law enforcement, street lights, basically everything that we rely on in our world, a lot of it, it's based on electromagnetic induction and proper functioning and operation of components that are inspected with eddy current testing. What are some of the fields that eddy current testing uses besides energy? Well, aerospace. Think about landing gear, airplane wings, the thin aluminum skin, or aluminium if you're in Canada, on an aircraft. Aluminum aircraft skin is only a couple millimeters thick. Why is it only that thick? Because aluminum is very strong. And it does a fine job as long as there's no cracks or other types of degradation such as erosion. So aluminum aircraft skins are routinely tested with eddy currents. Also landing gear, turbine blades, many different parts around the world at all airports and FAA repair centers. So just in aviation alone, tons of eddy current and lots of demand for eddy current employees that are skilled, qualified, and certified. Well, I mentioned aerospace and power generation. And then you got, think about SpaceX and Blue Origin. When they're sending vehicles into space, they're sitting on top of thousands of pounds of rocket fuel. You know, you got to make sure everything's structurally sound. You know, all the tanks and the valves and the rocket boosters and all that stuff. I'd imagine, you know, the landing platform, when the SpaceX vehicle returns vertically, all that stuff's got to be in good shape. So they probably test a lot of that with eddy current testing and other non-destructive testing techniques. Probably radiography, liquid penetrant, magnetic particle, visual. Let's move over to automotive. Think about a Formula One car racing around a racetrack, 200 miles an hour. I want to make sure all those pieces and parts of the automobile are good. So non-destructive testing is used in a lot of those components. What about manufacturing? Eddy current testing is one of the most widely used non-destructive test methods in manufacturing because it does a very good job at measuring things like dimensional tolerances. Think about an assembly line when you're manufacturing thousands and thousands of parts, you know, often per hour. You need to have dimensions checked. You need to have heat treating checked. You need to have, you know, thermal conductive type properties checked. You know, back in the 1950s in Germany, they were testing over 5 million parts per day using Dr. Forster's eddy current test equipment. That was in the 50s. That was only in Europe. So imagine worldwide today, with all the stuff that has to get checked, eddy current testing instruments and probes are deployed around the world and keep a lot of people employed, and more importantly, a lot of people safe. Food manufacturing, yeah, they use eddy current testing. What am I leaving out here? So we got energy, petrochemical. What about all the plants that have all the big tanks and pipelines? Those things need to be structurally sound. So you can use magnetic particle, radiography, liquid penetrant, ultrasound, eddy current, a combination of all of those different non-destructive test techniques to make sure that the tanks hold the millions of gallons of fuel often, and pipelines that distribute the different petroleum types, you know, across our nation, which also keeps the gas plants and energy plants operating, keeps customers happy. So I talked about eddy current testing quite a bit, and then non-destructive testing in general. But as you can see, it's a big business, and it's very important. And a lot of people have never even heard of non-destructive testing. You know, it's one of those things, you know what you know, and you know what you don't know, but you don't really know what you don't know. Non-destructive testing is one of those things for many. It's omnipresent, it's ubiquitous, it's everywhere. It's vital for our livelihood of mankind. And it's what I do. I've been doing it for 35 years. And I'm going to start posting more regular on my YouTube channel because I have a lot of knowledge about non-destructive testing and eddy current testing, and I want to share that knowledge with folks who are thinking about getting into the business of non-destructive testing, or people that are already in it but want to learn more about the different industries and the different methods, the different techniques, and also the implementation and use of AI in non-destructive testing, because like anything else, I mean, it's going to be a big part of our future. So we need to study it, understand it, so it can be properly deployed to the field and used in a safe, efficient manner to save time and money and increase the probability of detection of flaws, and in general, overall, to improve the entire process of non-destructive testing. I hope you enjoyed the video. Go to eddycurrent.com to learn more about eddy current testing. You can visit my Facebook, YouTube, and LinkedIn channels to learn much more about me and eddy current testing. Thanks for watching. Please like and subscribe.